Hello everyone, and welcome back to the Game Engine programming series, where I write a game engine from scratch. If you happen to have skipped over the past couple of videos because they were blue episodes, you might be in for a surprise because the user interface of the level editor now looks rather differently. We have a dark theme going on here with very different colors than we had before, and we also have got some nice animations here. But functionality-wise, nothing has been changed. I only made a couple of controls here that I could use to enter numeric data, like vectors and scalar values, using keyboard or just by dragging the components or the numbers using mouse. And today I would like to use these controls actually to make a transform component for our game entities, because right now the transform component isn't displayed. So I'll spend the time today to prepare displaying different kind of components and also actually make a control that displays the transform component. So first, before getting started, I would like to correct something I said in this video.
There is this bug in WPF, I think, that whenever I select multiple items in the list box, then it will have this disabled color. And, well, if you go back a couple of videos and look at the default style of the list box, then you can see that it happens there as well. So it's not something I just did, it's just like this all the time.
Which was totally wrong, of course, because although the colors of the selected items are incorrect, the bug is not in WPF actually, but that is caused by something I did before. And that's if we look at the world editor, in Editor's World Editor view, in the code behind, you see that I'm giving the focus back to the world editor control every time the undo list changes. And guess what? Every time we change selections, of course, the undo redo list is also changed, which gives the focus back to the world editor control. And that means that it takes focus from this list box. And that's why the background color of selected items is the color that the items would have when the list box was out of focus, which is, of course, true in this case. So the only thing I have to do to correct that is just to remove this line. And now, lo and behold, we have this blue background for selected items. This means, however, that occasionally we will lose keyboard focus to the entire interface, and that way we can't use hotkeys anymore. So for example, if I now press Ctrl Z, let me see, at some point, like now, for example, I don't have the keyboard focus to the entire application anymore. So when I press Ctrl Z, it doesn't undo the selection changed history. So that's something we still have to fix. But for now, it's for me more important to have a correct behavior in the user interface rather than just having the focus all the time. With that out of the way, let's prepare making the transform component for multiple selected entities. Now, if we look at the diagram for multi-selected game entities and the multi-selected component classes that we have, you can see that a multi-selected transform is needed for each multi-select game entity. And each of those components have a list of selected components. So for example, this MSTransform has a list of all the transform components that are in the list of selected game entities. So today I'm going to implement this class, MSTransform, and also make the WPF control for it to display the transform. Okay, first I am going to implement a base class for multi-selection components. Well, we have actually a base class here, an abstract base class. but it's empty. So I'll need to add some functionality to it in order to be able to use it with multi-selection components. And this class is basically the same as we did for multi-select game entities, or this base class MSEntity, in that it has two methods that would propagate the changes to all selected entities, and one for gathering the information from selected entities. And we will have a refresh method to update this instance of the multi-selection component. Because we are having multi-selection components instead of multi-selection entities, we'll need a list of components. We have a list of components here that corresponds to the type of component for the multi-selection component. For example, if we are making a multi-select transform component, this T would be of type transform. And we would have a list of transform components, which is exactly like the drawing that I just showed you. And here in the constructor, I check if there are selected entities, and this MSEntity is not null. And then I'll collect a list of components of type T into this list using this select function. And then I need two methods to propagate our changes to the selected components and to gather the information from those. This method will update the components, and this one will gather the information from the components. And we can also tell this method what property of that component exactly should be updated. For example, we have for the transform component position, rotation, and scale. So we can say, okay, you have to update the scale property of the transform. And the next line of code will make sure that all the components in the selected components list will be updated. So whenever one of our properties changes, then the corresponding property in any of the selected components will be updated. And this enable updates is to prevent a circular update. So for example, when we use this method, update MSComponent, to gather information that will change our properties, and then we'll have to disable the update so it doesn't propagate the changes back to the selected component. So I need a Boolean here that I can set. And we have a refresh method that sets the enable updates to true or false. So when we call refresh, the updates are disabled. So anything that we gather from the selected components doesn't propagate back to the components again. And that's all I have to do for MSComponent. Next thing I can do is to use this as a base class for the MSTransform class. Here in transform component, I can add a new class. As you can see here, the base class is MSComponent, and the type of component that we are collecting is transform. Now I have to implement those two methods to update and gather information. But first I need to define the properties that we want to change in the multi-select transform. And the way I would like to do this is to decompose all these properties from transform to their XYZ components. So for example, I'll have the position X, position Y, and position Z, and the same for rotation and scale. The first thing that we notice is that I'm using a nullable float, and that's because every time the selected components have different values, the value for the position X will be null. So if we have different X components for the position, then this will indicate that we have mixed values, and this floating point value will be null. And that's exactly the same as we did for game entity. If you look at isEnabled property, then we are using a nullable Boolean as well. And that's just because this mixed value methods return null if we have different values and return a single value when we have uniform values. And the second thing we should notice is that I can't really compare floating point values like this directly because of machine imprecision. And a while back, I created this utility method for comparing floating point values. And I can use this one instead of comparing floating point values directly. So if the position is not the same as the new value that we have, then we should set it again. And then I have to repeat this for Y and Z values and for rotation and scale. Using these properties, I can set the components of each property in transform components individually. And then I can implement these methods now. If any of the components of position has been changed, whether it was the X, Y, or Z component, I just return a new factor 3 instance to the position of each of selected components, or each of the transform components. And then I can repeat the same thing for rotation and scale as well. And this is all we have to do to update the selected components. It's a bit jejune, but that's all we have to do. Next, I'll implement this method that gathers information from the selected components. Remember that we had these methods implemented that we can use to determine if some property in a collection of game entities has the same value or not. And I want to use the same methods to actually do the same for a component. But these methods only use a game entity right now. So I'll have to rewrite them in a way that they'll also accept components. And the way to do that is just to make this a generic method that can accept different types of classes. If you haven't seen the video about the mixed values and why we did this, then feel free to go back and watch this video to find out more about what we exactly did here. For now, I'm just going to change this to a generic method. That means that it will take a generic argument of type t. Okay, now as you can see here, we can have different types. And if I go back to transform, you see that there is no error here anymore. But while I'm here, I can rewrite this a bit more concise. Here I skip over the first object because we are already having the value from that object anyway, so we don't have to examine it again. And then if any of other objects, in this case our component, will have this property and the value of that is different from the value that we got from the first object, that means that we have a non-uniform value and therefore we should return null. And if all the values are the same, then we just return this value. That means that we have a uniform value. And then I can do the same to the other two methods as well. Brilliant. Now they look less like they were written by a 5-year-old. Now we can continue implementing the Multiselect component, Multiselect transform component. I of course forgot to use nullable floats here, so I'll have to change those. By the way, some of you asked me to zoom in on a code a bit because it's apparently hard to read on smaller screens. So I made the text a bit bigger, and feel free to let me know if it's okay now. All right, the next thing I need is to actually refresh or call refresh to update this information. And that I can do whenever the instance of this multiselect transform is created. I just call refresh. Okay, next I'll have to fill in the list of components in the multiselect entity, because right now we have this list of components that we are not using anywhere. So I'll need a method to actually assemble the list depending on what entities have what components, because right now every entity has a transform component, but later on we'll have other type of components as well. But not all the selected entities will have the same list of components. Some of them will have a geometry component and some others will have scripts. So we'll need a method that will display the components that are common between all the selected entities. Here I go through every component in the first entity that we got, and then get its type. And if all other entities that we have selected have the same component as well, then we will be adding it to the list of components. Here I also assert that this type of component shouldn't be in the list of components already, then something is wrong. And other than that, I just add it to the list of components. But our list of components contain Multiselect component. And what we got here is like a regular component that any entity has. So we need to ask a component what its multi-selection variant is. And for that, I need to add a member to this abstract base class for components, a member method that will get me the multi-selection variant of that component. Now, if we go back to the transform components, you'll see that I have to implement that method. And it's really easy. All I have to do is to return an instance of Multiselect Transform class. Now, if we continue the implementation of MakeComponentList, I can call that method to get the multi-selection variant of this particular component. Okay, now I can already test this to see if this transform component is being included in the components list. Now, when I select one of these game entities, then you can see in the list of components that there is an MSTransform instance here. And now all I have to do is just to make a user control for this. First, I'm going to create a user control that I can use to display different kind of components. And what this basically is just an expander that has an item, which is the user control for the component that I want to display. In order to be able to actually set a header for a particular component type, for example, our transform component, and display its content, we need two dependency properties that we can use to set the header and to set the content of this component view. Okay, here I used a code snippet to generate this dependency property for me. And then I'll have one more for the content of this component view. And also I'll tell this user control what its default content property will be. I can use an attribute class for this. And this is just to make sure that I can use this content presenter to display the content without having to type content. So for example, in this text block, I can say, okay, if I have a text block, I can, or maybe a button. Let's put this in a grid. If I have a button, I can say its content is something, or a button and then button content is something. Or I can say, okay, here is a button and its content is this. And in the last case, I can put a content in a button without having to type in content. And that's exactly what I can do with the component view as well, by saying that whenever I don't type anything for the content, then it should automatically go to this component content property. And now that I have those two dependency properties defined, I can use them to bind to the header and to content presenter's content. Here I am referring to the component view. So basically this control where we are already in, and I'm bind the text of this text block to the header property of the component view. And then I can do the same for the component content. And that's it. I can now use this component view to display my transform component. First, I want to get rid of these namespaces with word editor in it. And do the same for component view. And here I just put in a grid with 3 rows for the position, for rotation, and the scale of the transform component. And I'll also have a column for the name of each row. For example, I'll put position, rotation, and scale titles next to the numbers. I also want all my text blocks to have the light font color. I would also like to have a design time instance of my view model, which is a Multiselect transform. Now, because the position, rotation, and scale are vector 3 type, I would like to use the vector box to display those components. For that, I need to include the namespace as well. And now I can bind the X, Y, Z to our position X, position Y, and position Z properties. And then, of course, I need to tell the game entity view, which also displays the components, that it should use the transform view that we just made whenever the component is MSTransform. So I'm using a data template here that says whenever data type is of type MSTransform, that corresponds to a transform view. And here, if a component is of type MSTransform, then that data template will be used. And now I can check if it works. Now we have here the transform component of the game entities. And I can check if the multi-selection works. I don't think our bindings are working for some reason, so I have to fix that. You see, I can change the values and nothing is updated. Let me see. Oh, now it's working. Let me try again to make sure that it's working. Okay. And this is the component view that we wrote, which was an expander. And our transform component is in there. What I haven't done yet is to set its title to display transform component. So I'll do that as well. Now our expander's header is transform. So I can set the name of each type of component that I will be displaying. And let's add some little formatting for the component view to make it just a bit nicer. Here I'm changing the background color of the component view whenever I go over it with the mouse, so it becomes a bit lighter. Okay, that's good. And the next thing I would like to do is to make the changes to our transform components undoable, because right now we can't undo anything. You see here selection changed, but no changes that I made here are actually recorded as undoable. I also made a couple of typos here. I need to change these. To make these changes undoable, I need to go to the code behind of the transform component view and record undo redo actions whenever something changes. Whenever we make changes to any of these values, we can do it in two ways. We can drag the value by mouse or input a value using keyboard. So we have to attach event handlers to handle those cases. Okay, let's try to implement these for the position first, and I'll repeat that for rotation and scale. So when I click on a value, I want to record the initial value of that number because that can change after I drag with the mouse. And for that, I just record an undo action. When we press the left mouse button, I remember all the components and the value of that particular property, so we can reset them when we are undoing the changes. Here I get the multi-selection transform component from the data context. And if the data context is null or it's not of type MSTransform, we do nothing. And then I'll just make a list of the transform components and their current value of their positions. And when we want to undo whatever changes we did, we just set back those transform positions to their old value. And then I want to refresh the MSTransform component, and therefore I need a method from MSEntity to get the transform component, the Multiselect transform component, in order to be able to refresh it. If we look at the game entity, the game entity class has a method here that I can use to get the components of type T. And I need to implement a method in the MS entity, just like the one that we have for the normal game entity. Here I look in the components list and see if there is any component in there of type T, and then return it. If there is no component of that type found, then this method will just return no. Okay. Now, when we release the left mouse button, then we have to check if the value was changed. And if so, we can record an undo redo action in the undo redo manager. In order to be able to track whether the value was changed, I need a Boolean field. Here I use an event handler that I'll attach to property changed event of my view model. And whenever any property of the view model has been changed, then this field property change will be set to true. And then I can check here in left mouse button up if the property was indeed changed. And if so, I can record the undo redo action. So to have a redo action, I need the current value of the position for each transform. And that's basically the same thing as we did here. Except that now instead of having the undo action, I'll have a redo action. And here I also set the property changed to false again. And as the last step, I'll just record the undo and redo action by adding it to the project's undo redo manager. And also here in left mouse button down, I need to reset the property changed. This is all we have to do to handle undo redo for changes that we make using the mouse. I can already test this. You can see we have a position changed item here. And then I can hit Ctrl Z and it is undone to 0 again, to its old value. I can try doing that for multiple selected entities. That works. And I can also redo everything again. Okay. Now let's handle the case where we change the values using keyboard, because right now these changes aren't registered in UndoRedo history. Here in Lost Keyboard Focus, I can basically call one of these methods again. So if the property was changed and we have an undo action, then I call on position left mouse button up to record an undo redo action. And we are using the preview mouse event, so we need to change the event handler's names accordingly. It's preview because I want to know when the mouse is down or up before this control gets the event and handles it, because otherwise, if you look at the number box here, after one mouse action, we set its e.handle to true, and therefore the mouse clicks don't get any further than this control. And if you want to know whether the mouse button was down or up, then you have to use the preview mouse event. Now I have to rename these. If you look at these methods, you can see that there is a lot of code repeated here. And I don't want to repeat all of these for rotation and scale as well. So I'm going to refactor as much code as I can. And the first thing I can do is just to get this part out of these methods, because you can see right away that's the same code basically. And here I can just call the new getAction method to set the undo action. And for the left mouse button up, I can also do this. Okay, so I refactored this part of the methods because that was in both of them. And now we can get undo action and redo action just by calling the new method. Let's see if that works. This is the one that I changed using keyboard. And this is the one that I changed using the mouse. And it seems like it works correctly with undo and redo. So we simplified the preview left mouse button down. If I have to repeat this for rotation and scale as well, then I have to repeat this part. And I think I can even factor out this part as well. Okay, we can use this method only to get the position information. So if we would like to implement these mouse event handlers for rotation and scale, then we would have to repeat this method. To avoid repetition, we can rewrite this method in a way that it can be reused for rotation and scale. So the part of this method that is different for rotation and scale is this part and this part. And the rest is, of course, the same. So if we can give this as the method parameters to the new methods, then we can have one method for different properties. We will have a function that I'll call selector that gives this method this part. So it's a function that will take a transform component and will give us back a transform component and one of its properties. And the second parameter is this part that will indicate what value should go to what property of the transform. So it's an action. Now, for example, I can have a getPosition action that will call this method. And as the method parameter, I can say, okay, I want to have this part. And the second parameter is an action. And now all I have to do is to use these parameters here instead of typing it literally for position. And then instead of calling getAction directly, I call getPositionAction. And I can easily have another two methods for rotation and scale by just copy pasting this and using the right property. Finally, I can even factor out this part so we can reuse this as well. For that, I'm going to write a new method that's called recordActions. And I can just move this here. And even I don't have to use this local variable. I can just call getPositionAction directly here, and that's it. And this makes it very easy for us to implement these two methods for rotation and scale as well. I just go and copy paste these twice, and we'll change these to rotation. And these ones to scale. And then I can copy paste this for rotation and scale again for handling keyboard. And then I have to attach these event handlers to the right events in the XAML file. And now I can test if they are working correctly. Okay, one thing that I need to do is to take away the focus from the text box when we start dragging another value. Right now we have the focus to this rotation X component, and we still can change some other value. And when we hit enter, then this rotation is changed. I don't really want that. You can see both numbers changed as well. Not something I want. And to solve this problem, I just go to number box, and whenever we click on a value, I give the number box the focus, which will take away the focus from anything that has the focus at that moment. Now, if I have the focus on one of these text boxes, and then I can use the keyboard to change the value. And while I'm doing that, I start dragging on another value, then the focus will go away from what I was doing and it will be reset to its initial value. All right. And right now we have another little bug here whenever I change the name of game entity, and I go back by undoing it, like so, and then just give this text box the focus and hit escape to remove its focus. Then you will see rename game entity here. And the reason is that if you look at what's done in game entity view, we are having this property name. Whenever the property of the MS entity changes, then the name of the property that was changed is set here. And while we are undoing, of course, the properties change. So we have to set this property name to an empty string again whenever we are starting to record new actions. So here in getKeyboardFocus, I have to set property name to an empty string. And that kind of solves the problem. Now, if I select this text box and hit escape, then nothing happens. One last thing I want to do is to go to this dictionary. Here we have the event handler for lost focus. I think I want to remove this move focus and see if this text box is not visible, and if so, then we don't have to do anything. And in game entity, I just want to do a little improvement in isActive. If the isActive value is not true, then I want to check if this entity ID is still valid, because we don't want to remove some entity that already has been removed. And when we remove the entity, I want to set its entity ID to an invalid value. And that's all I wanted to do for today. We did a lot of work. We now made it possible to add new kind of components in our game entity view. Right now we have the transform component, and we can change those and undo and redo them, which is nice. For the next time, I'll start actually working on the scripting system, which is the part that we can use to write the game code. And that way we'll be able to actually make games with our game engine. But therefore, we need a script component, which I'll start implementing in the engine itself. So the next video will be a red episode working in C++. And actually, the next couple of episodes will be red as well, because I'll be mainly working in C++ part, which is the engine, to lay the ground for creating the scripts, the game code, and loading the game code in the engine and in the editor, of course, because we'll be running the game code when we press play game in the editor. So we need to be able to do all that. So it will be rather involved, but also a lot of fun to implement. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!